The question says the given chemical reaction is called, first is Hunsdiecker reaction, second Swartz reaction, third is Strecker reaction, and fourth is Wurtz reaction. You can see all are these name reactions, and if you look at the reaction, you can see this is halogen and this is also halogen. It means that halogen exchange reaction is taking place. And about halogen exchange reactions, we have learned there are two types of chemical reaction. First is your Finkelstein reaction and second is Swartz reaction is there. In Finkelstein reaction we have, you might have learned Finkelstein reaction is there. In case of Finkelstein reaction, highly electronegative, a more electronegative halogen is replaced by less electronegative halogen. Let me write this chemical reaction. We have CH3, let's say Cl is there, and it is reacting with NaI, and in this case we use as a solvent dry acetone. We have dry acetone is there. Okay. Now in this case you can see this halogen attached to the alkyl group will be more electronegative. This is the condition, and this iodine attached to the metal should be less electronegative. Then halogen exchange can take place. If we switch the position of halides, reaction will not take place. Okay, halogen exchange reaction will not be taking place. So this is the condition we must abide by to complete the halogen exchange reaction. So in this case what will happen, iodine will come in place of chlorine and chlorine will go in place of iodine. So we get the substance. This is what we have, CH3, I is there, and we remove NaCl is there. Okay, so this is the condition for the Finkelstein reaction. Second, we have Swartz reaction. Keep in mind, Swartz reaction is used to produce only alkyl fluoride. Swartz reaction is used to produce only alkyl fluoride. Let's say any halide we can take other than alkyl fluoride. Let's say we have CH3, it is Cl is there. In this case we can use the reagent, any of the reagents. Let's say we have AgF is there, or we can use COF3 is there, SbF3 also we can use, or we can use Hg2 and F2 is also there. Any of these four reagents we can use, and halogen exchange reaction will take place. Halogen will be exchanged by fluorine. Okay, you can see fluorine, and fluorine is there. So we get CH3, it is F is there. Okay, so you can see out of these two methods for halogen exchange, only Swartz reaction is given here. Swartz. You can see Finkelstein is not given here. Then we can select this is second option is correct, Swartz reaction. And you can see, as we have learned, Swartz reaction is used to produce alkyl fluoride. If you look at the product, you can see this is what ethyl fluoride is there, ethyl fluoride. And we have AgF. You can see AgF we have used here. Very interesting. Now we can understand about this reaction. You can see Strecker reaction is quite a unique reaction is there. I don't think this is given in the syllabus, but still we understand what this reaction is all about. Okay, so we have a Hunsdiecker reaction. Keep in mind, Hunsdiecker reaction is also used to produce alkyl halide, but this is also an example of a decarboxylation reaction. Okay, we are talking about Hunsdiecker reaction. In this case what happens, silver salt of acid is taken, silver salt of acid, and it reacts in the presence of red phosphorus. We have halogen is there, Br2. Keep in mind this reaction takes place via free radical mechanism. To support the entropy, this CO2 in the form of gas will escape, and keep in mind from here we get two Br dot, and here we have the Br dot. Here we got Ag dot and R dot is there. So you can see R dot will combine with Br dot, RBr. You can see alkyl halide is there, and Ag dot will combine with another Br dot, so we get AgBr is there. Okay, so this is the reaction we have. Next we have Strecker reaction. Okay, Strecker reaction is there. In this case we produce alpha alkyl amino acid. Keep in mind it is used to produce alpha alkyl amino acid. Alpha alkyl amino acid is there. Okay, and this reaction takes place in three steps. In the first step we use ammonia, second step we use cation, and third step we use water molecule hydrolysis. Okay, let me write this chemical reaction. In general, carbonyl compound is taken. Let's say we have aldehyde, RCH double bond O is there. Ammonia can also be written as HNH2 is there. Okay, this is active hydrogen from ammonia can be removed. So if you break this bond, so it will carry negative charge, it will carry positive charge. You can see polar bond is there. Oxygen will carry partial negative charge, carbon will carry partial positive charge. So positive negative attraction will be there. Here we have the positive negative attraction. Then we get R, and it is CH is there. Here we got OH, and then we have NH2 is there. Next we have cation. You can see strong nucleophile is substituted by weak nucleophile. KOH from here is replaced. Then we get RCH, and this is what the CN is there, and this is we have NH2 is there. And we have learned when one water molecule is added to cyanide, group, it converts into aldehyde, and if you take two water molecules, CN converts into COOH. So here we are carrying out the hydrolysis reaction. So we get it is RCH, and this is COOH is there. This is what we have, NH2 is there. So you can see this is alpha amino acid. Alpha alkyl, this is alpha alkyl amino acid is there. Okay, alpha alkyl amino acid. So keep in mind, Strecker reaction is used to produce alpha alkyl amino acid, and this reaction takes place in three steps. First step ammonia, second step potassium cyanide, and third step is what? Hydrolysis reaction. Okay. Next we have Wurtz reaction. About the Wurtz reaction, you might have learned, this method, this name reaction is used to produce a symmetrical alkane. This is very good method to produce a symmetrical alkane. Keep in mind, this reaction is not fit for the production of unsymmetrical alkane. Why? Because if we try to produce unsymmetrical alkane, we get a mixture of alkanes. That's why again that we have to segregate that mixture into its components, becomes a tedious task. Okay. In case of Wurtz reaction, you might have learned, we are talking about the D option. You can see alkyl halide is there. Alkyl halide react with in the presence of sodium, but in this case we use dry ether as a solvent. And we take two molecules of alkyl halide. Two molecules. You can see one sodium can combine with one Cl. Since there are two Cl, so I take two molecules of sodium are there. So this entire portion will be segregated. Okay, so we got a 2 NaCl. 2 NaCl is segregated from here, and you can see this is alkyl group. This is also alkyl group, and here we got symmetrical alkane. R is there. This is the symmetrical alkane. Best method for the production of symmetrical alkane. So you can see this name reaction. Yeah, this reaction is called as a Swartz reaction. Option B is correct. If you like this video, please share and subscribe to the channel.